Okay, so today I'm going to solve the problem number lead 133 clone graph. So the problem says given a reference of a node in a connected undirected graph, return a deep copy clone of the graph. Okay, so to solve this problem, what I'm gonna do is I'm going to use the graph BFS traversal. So what we will do is we have this graph looking like this: 1 2 4 and 3. What we will do is we will create one queue for processing and we'll create one hash map for cloning. So for the very first time we'll add our first node into the queue for processing, and we'll check and we'll simultaneously add that node into our dictionary or hash map for cloning. So once we add that as a node, we'll generate a hash map with key and value like this. So what we'll do is we'll process this current node and we'll see if its neighbors are there in the dictionary or not. If they are not, then we'll add them again as node. So this is how we can do it in code. So we'll define first, if there is no node, then we'll return the empty node. Now we need one queue, so we'll use dq and we'll add our first node, and we need one hash map for cloning our node, and we'll add our first node into the hash map. So this is how we do it in Python using the definition of the node dot value. Now we'll start the processing in dq. So we'll say while q is not none, give me the current node. So we'll pop out the current node from left, and we'll start looking for its neighbor. So neighbor in current node dot neighbors. So if my neighbors are not in scene, then we want to add them. So scene of neighbors is equals to add that neighbor as a node in my hash map, and again add that neighbor for processing into the queue. And if that neighbor node is in the dictionary, then we directly want to add that into my neighbors of the current node. So we'll go into the neighbors of the current node and we will append them. Neighbors, yep, dot append, seeing that neighbor right, and at the end we want to just return our hash map which we initialize with this. So this is what we are doing. So for first we go into the dictionary and we see there are no neighbors in the scene, so we'll create those two again neighbors for those two neighbors in the hash map, and when we are coming out, then we will add those into the neighbors of the current node neighboring list. So we'll add there 2 and 4, and we are appending that into our uh, DQ for processing as well. So for here we add 2 and then we have added 4 again. Now at the very first, now again we'll use 2 for processing into the DQ, and when we go and we'll see that the neighbors, what are the neighbors for the current node, which is 2, they are 1 and 3. So we'll find that 1 is there in the scene dictionary, so we don't need to add that, but 3 is not there, so we need to add 3 into our scene dictionary. So we'll add that, and we'll add the neighbors in the current node, so which are 1 and 3. So we'll add that over here, and then we go for processing of 4, and but before that we'll need to add the 3 in the DQ for processing, and after that we'll go for node 4 for processing. It has all the nodes in the dictionary, so we'll just keep adding the neighboring items of 4, which are 1 and 3 in the neighboring list of 4. Then we'll go for 3, and 3 has the two neighbors 2 and 4, which will be added into its neighboring list. And that's how you clone a graph. Let's run our code and see how it is working. So it says scene. Okay, scene is not there, so scene, and it has accepted. Let's submit it, and it's been accepted gracefully. So that's how you solve this Leetcode 133 clone graph using BFS. Thank you.